Hello there, I'm Michelle, licensed massage therapist from Washington, and I bring you MBLEx resources for helping you to succeed on the massage and bodywork licensing exam with calm and confidence. I have videos here on YouTube that are available to you absolutely free. I also have lots of free resources on my website. I have eBooks, courses, practice tests. I have all kinds of stuff to help you to get everything dialed in that you need to know for the massage and bodywork licensing exam. So go check that out. There will be a link in the description below, also in the first pinned comment for you to get to all that stuff, a whole link tree that's got all the stuff. Today in this video, what we're going to be talking about is some kinesiology basics for the massage and bodywork licensing exam. Now, I am going to be doing a whole kinesiology course. That's my next project after I finish the anatomy and physiology stuff, is I'm going to make a course for kinesiology where I will extend all of this information that I'm going to be presenting to you, and it's going to be a full thing as though you are in school again. And it will help to reinforce if you are in school and you're not ready to take the test yet, but also if you've taken a break for a long time and you need to relearn everything, then it'll be there for you. But this is just the aspects of kinesiology that are presented from the perspective of just the anatomy and physiology book. This is the book that I'm working off of. This is just the review guide, but my book's upstairs. But anatomy and physiology in that textbook has a little section that has to do with kinesiology. So this rounds out the four videos in my skeletal muscle section, and then we're going to move on to working on the nervous system, learning more about the nervous system, and then we're going to learn about how the nervous system connects to the skeletal muscle system. But yeah, this rounds everything out, so make sure and check out the other 3 videos for the skeletal muscle system. And in this video, we're going to be talking about what kinesiology is, the types of skeletal muscle, that's the shapes of these different kinds of skeletal muscle, types of contractions. We're going to talk about levers in kinesiology, some general terms that you need to know, and then we're going to introduce range of motion testing. I'm not going to be demonstrating any range of motion testing in this video. That's going to be saved for kinesiology. And then we're going to do some MBLEx practice questions. Okay, so if all of that sounds like stuff you need to know, let's go ahead and get started. So kinesiology is the study of how muscles, bones, and joints work together to create movement. And for massage therapists and body workers, it's where anatomy comes to life. So understanding how different muscle types generate force, how levers amplify motion, and how contractions vary from subtle tone to powerful effort gives practitioners a deeper awareness of what's happening beneath their hands. You need to learn terms like agonist, antagonist, synergist, and reciprocal inhibition to build a framework for interpreting muscular relationships while recognizing fast versus slow twitch fibers and phasic versus postural patterns, explaining why muscles fatigue quickly and others hold tension. This knowledge empowers body workers to assess range of motion more effectively, target imbalance, and apply techniques that truly enhance functional movement and recovery. Okay, that's all the reading that I'm going to be doing out of this video, but I just think that's such a great intro. The language of movement, that's what kinesiology is. So first we're going to talk about the different types of skeletal muscle shapes, right? The way that the muscles are structured determines the kinds of action that they make. If you want to learn more about each of these muscles and the actions that they make sure and check out my Muscle Masteries video. There'll be a link to it in the pinned comment and also in the description, so make sure and check out that. So the directions of the fibers and the way that the fascia divides them in relation to the tendon also determines the movement. And there are 2 main divisions of muscles, and those are parallel muscles and pennate muscles. So parallel muscles are the same length and in parallel arrangement. Here's a demonstration of parallel muscles. That's rectus abdominis. Okay. Also sartorius is a parallel muscle. So it can produce movement over a wide range of motion because all those muscles are parallel, okay? So like it makes big movements, but they're not necessarily powerful. Under the umbrella of parallel muscles, we also have fusiform muscles, which have a thicker, broader belly, and then they taper to the ends. They focus the point of contraction to a specific area. For example, the gastrocs and the bicep, they help with contracting those big joints, those big significant joints like our elbow, which is the radial humeral joint, or the humeral ulnar, sorry, say it right, humeral ulnar joint, and then also the tibiofemoral joint are both flexed thanks to fusiform muscles. And then we have circular muscles, which are considered to be parallel as well. Contraction and relaxation opens and closes an orifice. So we got orbicularis oris around the mouth, and then we've got a similar one around the eyes, and then we have a similar one around the other end, where the other end of the gastrointestinal system. And then finally, the last parallel form of muscle is called a triangular or convergent muscle. Both terms are true. One end is spread out like a fan and then attached over a broad area, and the other end all comes into one point. So pec major is an example of that, and it's great for multiple lines of pull. You know how you can abduct your arm over a wide area. Also, it helps with arm flexion as well. So yeah, all of that broad area makes it so that you can go over a huge line of pull. Not necessarily all that powerful though, because it is still a parallel muscle. And so now we're going to talk about pennate muscle group, the pennate muscle group and the muscles that go under that. They're multiple lengths of fibers running in an oblique line to attach to a central tendon. They're more powerful, but over a shorter range of motion. So here's an example of a unipennate, that uni meaning one. Make sure and check out my medical terminology book so you can see all the different word roots. So uni means one, pennate means feather, okay? So like a flag, the fibers converge on one side only, okay? The force of contraction can only move in one direction. So just shoop that way. So this would be a wrist or hand flexor. So it just pulls those fingers up, okay? Extensor digitorum. A bipennate muscle means it's got two sets of feathers, right? Looks like a complete feather. So they run on oblique lines from either sides of a tendon, giving feather-like appearance. The force of the tendon pulls the fibers from two sides at once. Okay, rectus femoris being one of those. So we know rectus femoris can flex the hip and it can also extend the knee. So yeah, it does a good job pulling from either end and it keeps things balanced pretty well too. And then multipennate fibers run in two or more branches, which has its own bipennate arrangement. So there can be a bipennate happening in the anterior fibers of the deltoid, and then the middle fibers and the posterior fibers of the deltoid. And that makes it so that you can do all of that abduction from the posterior to the anterior side. You can use the deltoid fibers for all of that movement. Okay, so that's it for the types of muscles. Now we're going to go into types of contractions. So there are many different kinds of contractions. Some of them can create movement, but a lot of the contractions that we have don't create movement at all. And so we're going to go over that. But first of all, I want you to understand tone. Muscle tone is a constant, partial, involuntary state of contraction. So we have contractions that are involuntary involuntary that are just happening because our brain, it just knows what to do in order for us to stay alive. So that's what tonic contraction is. It's only enough tension. Tonic contraction is only enough tension to hold a body part steady. So it maintains your posture in your neck, in your torso, and in your legs when you're standing. Also, sometimes, like I find myself, excuse me, I have a little phlegm. Sometimes I find myself holding muscles that I shouldn't, and they're in a tonic state. Say, for example, when my shoulders raise, or when my neck is tense, or sometimes the adductors between my legs will be tight for no real reason. Those are tonic contractions. All right, so the next section is isometric, where there is a higher amount of tension than a tonic muscle, but it still doesn't move. So if you're just holding a book or holding your cup of coffee, you're not having it braced by anything. That's an isometric contraction. So imagine that you're pushing against a wall, your muscles are engaging, but you're not creating movement. So it's like that. You're holding your cup of coffee, you're pushing your arm against a wall. I have this image of a person flexing their muscle. That's an image of someone doing an isometric or even a tonic contraction. They're not creating movement, they're just making the muscle bulge. Okay, and then so finally we have isotonic. Tonic and isotonic are not the same thing. I think that has to do with movement. So isotonic are the contractions that make your limbs move, okay, that make the things move. So there are two different kinds of moving contractions. There are concentric isotonic contractions, and there are eccentric isotonic contractions. Here I have the image of each of those. Concentric muscle contractions are when you are picking something up, the muscle fibers come together, the muscle shortens, and something moves, right? And eccentric, I also look at it as concentric because it's weird, right? I'm sorry, did I say concentric? I'll say this again. Eccentric, I also see as eccentric because it's a weird one. It's where you're slowly, carefully lowering something that's heavy, and the muscle is engaging, but it's lengthening. So that's an isotonic contraction as well. The attachment sites go further apart, and it helps you to maintain control over something that's heavy. Concentric means you're picking something up, you're making the muscle shorter. Eccentric means you're lowering something down, you're making the muscle longer. Okay, so another division is there are postural muscles and there are phasic muscles. So this is the same thing as looking at tonic muscles, which help you with your posture. So specific muscles in your body do their best work by just maintaining your posture. So your erector spinae group, your trapezius, your quads, they help you stay upright. And they perform for long periods in a semi-contracted state. They help with body alignment, resist gravitational forces, provide support for the spine and joints, and enable fine motor movements. Generally, in a clinical setting or in a therapeutic sense, they can become short and tight. So, for example, postural muscles such as your trapezius and your pecs, when you're just like holding yourself in position, those muscles can become short and tight, which creates that discomfort for your clients. And then for phasic muscles, those are the ones that perform the major movements. They work quickly and strongly, but for shorter periods, they tire out more quickly. Those are found more in your joints, and they generate efficient movement. And in the pathological or therapeutic perspective, they can become longer and weak. For example, your rhomboids or your ESGs. Well, no, ESGs would be a postural. So let's say your rhomboids or your piriformis or your glutes can become long and weak because the postural muscles have been holding everything tight. So you want to stimulate those to wake them up and get them to engage more. Okay, so other different types of fibers within the muscle are categorized as slow twitch or fast twitch. So here's a little diagram that I got. Slow twitch muscle fibers. So you see how there's different kinds of fibers within a muscle. Let's say this is a chunk of bicep brachii, okay? And remember from our last video where we talked about muscle contractions, motor units will activate different bundles of fibers. So we can use them for different things. So the slow twitch are the endurance fibers for slower, long-term, or postural contractions. They just work more slowly and they don't tire out as quickly. And then we have two different types of fast twitch. It's just like medium fast twitch and faster fast twitch, which are better for working quickly when you really need to sprint or like pick up something really heavy, stuff like that. So those are the white muscle fibers. All in one muscle, different types of muscles. Oh, I forgot to write in here, fast twitch 1B or 2B or 2A. I have to figure that, I have to remember that. I'm gonna put it in the PDF. There's 1A and it's either 2A or 1B. I'm gonna look that up and put it in the PDF so that you can print that out and get the right one. Okay, so in kinesiology, we have different kinds of levers. We have three different kinds of levers: first class, second class, third class. They have the fulcrum, which is the pivot part. They have, and that's the weight of the body part. Or sorry, fulcrum is the pivot part. And then the resistance is the weight of the body part. And then the force is where the muscle is contracting and pulling from an attachment of that muscle. So the first class, which doesn't happen very often in the body, but one example would be extending your head at the neck, right? So the atlanto-occipital joint would be where the fulcrum is. It's in the middle. The resistance is on one side and the applied force is on the other. So the resistance would be the weight of your head. You're looking down, you're looking at your phone. The fulcrum would be at the joint. Your splenius capitis pulls on that muscle at that tendon. Don't do that. It pulls on the muscle right there and it erects your head into position, into an erect state. You're like, what? Did you say something? And your head pivots up because that splenius has pulled your head up. Okay? So that is a first class lever. Second class lever is where the resistance, is not in the middle. I need to write that down. So I do have some editing to do on, let's see, resistance is on the, resistance is in the middle. Oh, I'm confusing you guys, I'm sorry. Second class is resistance is in the middle. Okay, so that's the weight, the applied force of the muscle tendon pulling up. I have somebody coming into the office, so there's going to be some noise of some other people talking. I hope you can tune that out. So anyway, the applied force of the tendon is on the outside, and the fulcrum, that would be the ball of the foot, is on the side. Resistance is in the middle. So there are not very many of the second class levers in the body, but here's one example. Okay, so I did do that one right. Okay, third class lever, which is the most levers of the body, and that's like our arms and our hands and our legs and our feet. Okay, so the fulcrum is going to be on the side, on the outside. The force is going to be in the middle, pulling up. So there's the bicep tendon pulling up, and the resistance would be the weight pulling down. Okay, so the applied force is pulling that weight up. All right, so those are your levers. So some general terms for kinesiology. We've got the origin, which is the fixed, non-moving muscular attachment, where the tendon is attaching to a bone and it's not moving. And then we have the insertion, which is the place on the bone where the muscle attaches that moves the contraction. And sometimes they can switch places. There are some muscles where they switch places, such as in the abs or in the lumbar muscles. Also, psoas muscle will do that as well, where it'll switch back and forth. Oh, I think also like our sternocleidomastoid will do that as well. It depends on what you need, but generally there's one origin and one insertion, and that lets you know what is generally the pull. Hypertrophy is when the diameter of a muscle grows because you've been using it. Atrophy is where there's wasting or shrinking specifically of a muscle. I did want to include on here that we have hypertonic, tonic and hypertonic. So tonic is when you have like a baseline of tension in a muscle, and a hypertonic is where it's unnecessarily tense. So those are what we're dealing with when we're doing body work and massage therapy. Some more terms. Agonist or prime mover. It's a muscle that generates most of the power for a movement. In this case, so I'm going to go through and talk about this. In this case, we have the bicep brachii, which is the prime mover for elbow flexion. All right. And it's the agonist also. The antagonist muscle would be the triceps brachii when it comes to the flexion of the elbow, right? So it is the muscle that does the opposite action, which would be extension. If your tricep is tense, it's going to be hard for your bicep to flex, okay? A synergist is a muscle that assists in the movement. So for elbow flexion, the synergist would be brachialis and brachioradialis. Those are synergists for the movement of elbow flexion. A muscle stabilizer. A stabilizing muscle is a muscle or a set of muscles that stabilize a joint. Oh, there's a typo I need to fix. Stabilizes the origin end of a prime mover so that the movement is more efficient. So here's an example. We've got the rotator cuff here, and then there's the deltoid that attaches to the tuberosity here, and it comes up and attaches on the acromion of the scapula. So you see that the rotator cuff muscles stabilize the shoulder, stabilize the humeral joint here, and it makes it so that the deltoid can abduct the arm. All right, so that's what stabilizing muscles mean. And finally, reciprocal inhibition is a reflex mechanism that switches off the antagonist when the agonist needs to contract. So I'm going to explain reciprocal inhibition in the context of the triceps versus the biceps muscle. You can't flex your bicep if the tricep is tense. So your nervous system sends a message down to that tricep to shut up and stay still so that you can flex that bicep. And vice versa. If you want to reach backward by extending your elbow, your brain is going to send a message, or actually it would be your spinal cord because it's a reflex mechanism. Your nervous system is going to send a message to your bicep to be quiet, stay still, so that you can extend your elbow by contracting your tricep. I hope that makes sense. And then we're going to talk about range of motion testing. Just briefly, I'm not going to go through and talk about a range of motion testing on every single limb. That's something to be saved for a proper kinesiology course. But in this context, we're just going to go quickly over range of motion testing and what it's for. So it's the measurement in degrees of the movement of a joint. That's what range of motion means. So there are 3 different ways that manual therapists can test the range of motion on a joint of a client. The first thing is the active range of motion. That's when a client actively contracts a muscle through a specific movement. So we're saying, okay, well, you go ahead and abduct your arm at the shoulder that, and just do it by yourself and see how you feel when you do it. And you just ask, do you have any pain or discomfort? Where is that going to be at? And then the next thing to do is to tell the client to completely relax as you move their body part through that range of motion. So that's called passive range of motion, PROM. And so you have them stay totally relaxed. You move it through the range of motion and test how it feels at the very end of their, like, see how far they can go. Ask them if they have any pain or discomfort. This assesses joint and inert tissue flexibility, and also tests whether or not you have joint or inert tissue. That would be ligaments and the joint capsule and cartilage. So it's assessing if there's discomfort in those joints, in those tissues that don't contract, because they are not contracting their muscles. And then finally, resisted range of motion would be to close out the testing. Like, if you see that they've got discomfort with active range of motion and they don't have discomfort with passive range of motion, then and then you hold their arm down and have them try to abduct their shoulder, and they have discomfort or pain, then you know that it's a contractile tissue in the RROM, resisted range of motion. And so, yeah, I'm explaining here what we're looking for, whether inert tissues, which are the ligaments, cartilage, joint capsules, are to blame for their discomfort, or if it's the contractile tissues, which are to blame. And then from there, we can identify which contractile tissues are involved by doing resisted range of motion in different planes to isolate which specific muscle or which groups of muscles are involved that we need to do some treatment on. And then with passive range of motion, there are 3 different end feels that we need to keep in mind. So a soft end feel is from soft tissue bumping together. That's ideal in, like, say, for example, when we're working on extension of the hip from the back end, from the posterior side, and we go to lift that leg up, and the tissues of the glutes are bumping into the hamstrings. That's going to be a soft end feel. Now, a firm end feel would be from tissues being stretched and reaching their limit. So when we're going to extend the elbow, and that's as far as it will go because we have ligaments that will keep us from going too far. And then hard end feel is when 2 bones bump together, and that's not ideal. All right, so that's all the information you need to know for that topic. And so now we're going to go through some practice questions to see how well we remember everything, and to also just make sure and dial in all that information. So first question is, which of the following statements incorrectly describe the common fiber arrangements found in the body? So we're looking for the wrong answer. There are going to be 3 correct answers. There's going to be 1 wrong answer. Common muscle fiber arrangements found in the body. So remember, we had that list of 7 different fiber arrangements, shapes, types, that's what we called them. So let's go through and look at them. A, parallel muscles have fibers running along the length of the muscle, okay, allowing for greater shortening and speed, but that's not true. So that first part is true. Greater shortening and speed would be with the pennate muscles. Parallel muscles are for greater range of motion. B, pennate muscles have fibers that attach obliquely to a central tendon. True. Generating more force but less range of motion. I like that. B is good. So C, convergent muscles have fibers that fan out from a broad origin and converge in a single tendon. That's true. Allowing versatile movement. Okay, so that's true. And then D, circular muscles have fibers arranged in long parallel bands, ideal for stabilizing joints rather than controlling openings. Oops. Uh-oh. Did I have 2 true ones? Did I do it again? Darn it. Okay, so parallel muscles have fibers along the length of the muscle, allowing for greater shortening and speed. I feel like that should be wrong. That should be pennate. And also, circular muscles are for controlling openings. So both of these are wrong. Well, let's see what, I think I just wrote this wrong. Okay, so D is incorrect. But I think also A is incorrect. But if I had to decide on one of these, I would definitely decide on D, because circular muscles are definitely for controlling openings. But I also think that pennate muscles are greater for shortening and quicker shortening and speed. Okay, so what does it say here? Convergent muscles are all accurate descriptions of real muscle fibers. Let's see. Parallel, pennate, and convergent muscles. Okay, well, sorry guys, but I clarified it. So which statement best distinguishes between concentric, eccentric, and isometric muscle contractions? So we're looking at the true statement that distinguishes between these three types. Remember, concentric is where the muscle shortens, eccentric is where the muscle lengthens and movement happens. So both of these are concentric and eccentric isotonic contractions, or where movement happens. Isometric is where the muscle contracts, but there is no movement. Okay, so let's look at which statement matches that. Concentric contractions occur when a muscle lengthens under tension. Eccentric, okay, concentric is it lengthens, that's not true. Eccentric is when it shortens, that's not true. Isometric, it stays relaxed, that's not true, because isometric, it does contract. Okay, let's try the next one. Concentric, B, concentric contractions shorten the muscle as it produces force. Eccentric contractions lengthen the muscle under control, okay? And isometric contractions create tension without changing length. B looks like a good one. C, concentric and isometric contractions both lengthen the muscle, not true, while eccentric contractions shorten, not true. D, isometric contractions require joint movement, while concentric contractions stabilize posture. Okay, so isometric contraction is where there is no joint movement and a contraction. And what contractions that stabilize the posture are your tonic contractions. Okay, so B, concentric contractions shorten the muscle as it produces force. Eccentric contractions lengthen the muscle under control, and isometric contractions create tension without changing length. So here's a quick explanation of that. These three contraction types describe how muscles generate and control movement. That is, concentric is shortening, eccentric is controlled lengthening, as in lowering a weight, and isometric is tension without visible movement, as in holding a plank. When you're doing that plank exercise where you're holding your body up in the air. All right, here's another question. Which of the following statements about levers in the body is correct? So we're looking for the one correct answer about levers. Remember, we had three classes of levers. A, first class levers have the resistance between the fulcrum and the effort. Now remember, in first class levers, we had the fulcrum in the center, so that's not true, okay? B, second class levers place the fulcrum between the effort and the resistance. Now remember, with second class levers, we had the fulcrum was on the ball of the foot. The resistance was on the outside. No, the resistance was in the middle in a second class lever, because we had the body weight, and the force, the force of the tendon pulling up on the brain. It's right there. Calcaneus, the calcaneal tendon. The force pulling up on the calcaneal tendon was on the outside. Okay, so let's see. Fulcrum between the effort and the resistance. So that's not true. Second class lever is not in where the fulcrum is in the middle. Third class levers place the effort between the fulcrum and the resistance. That's true, because remember, we had that example of a person curling a weight with their bicep, and the weight was on the outside, and the effort, the energy, was the bicep tendon pulling up, and the fulcrum was in the elbow. So C would be correct. Third class levers are rare in the human body, which is not correct. Okay, so the answer would be C. Third class levers place the effort between the fulcrum and the resistance, as seen in the bicep, as the bicep flexes the elbow. So most muscles in the human body operate as third-class levers, where the effort lies between the fulcrum and the resistance. This setup sacrifices mechanical advantage for speed, precision, and range of motion, ideal for fine motor control and functional movement. Looks like we have one more. Which statement best describes the difference between passive and resistive range of motion and what their results can indicate? So we're looking at passive range of motion and resistive range of motion. Remember what each of those were. And statement that best describes. So we want to find one correct answer. Or the best answer out of all of them. Best describes. That's something that's really important when you're doing the MBLEx, is remember that some of them may seem like they're good, but we want to find the best answer. Passive is when we lift their limb or body part and they remain relaxed. Resisting is when we put force against the body part and ask them to engage the contractile tissue. So let's look for the true statement. A, passive ROM is performed by the client without assistance. And that's not true. Passive is where they relax, okay? So let's skip that. B, passive range of motion assesses the client's strength. No, passive is where they remain relaxed, while resistive range of motion measures flexibility and feel. No. So passive range of motion, C, passive range of motion is performed by the practitioner without the client's effort to assess joint and soft tissue flexibility and also inert tissues. And then while resistive range of motion tests muscle strength and pain response under force, under load. So C would be correct. And then D, passive range of motion and resistive range of motion both primarily measure the nervous system's coordination rather than the musculoskeletal system, which is not the truth at all. So I pick C, which is passive range of motion is performed by the practitioner without client effort to assess joint and soft tissue flexibility plus inert tissue compromise. And then while resistive range of motion tests muscle strength and pain response under load. All right, so that's it. That's it for the skeletal muscle portion of the anatomy and physiology course. And stay tuned. In the next area, we're going to be talking about the nervous system. And I look forward to seeing you over there. Make sure and get the PDFs of these videos. I just have the slideshow set up. There'll be a link in the description and in the pinned comment. And I will see you all in the future videos. Toodaloo.